Yes, happy Republic Day to all of you guys. So, I welcome you all onto this wonderful platform Gradeup. Yes, guys, Rishabh, hello dear. So, today we are going to see the rest part of the theory of machine in this wonderful qualifier series. As you guys know, only 3 topics were pending. One was cam, governor and gyroscope. So guys, today we will be completing those topics with reference to gate. No doubt about that, they are less important for gate, guys. But yes, as they are the part of gate syllabus, so we will be discussing that for sure. Good evening, Shrikant Body. Aju Menon, hi. Chaliye guys, Manoj. Yes, same to you dear. Okay guys, so today we are going to start the 3 pending topics. Okay, so yes guys, first of all I would like to make an announcement that on 31st January 2021 you guys can have a free All India mock test. Register now for free and you can know your AIR and detailed solution of that test so that you can know where you stand in your GATE 2021 preparation dear. Okay, so let us move further. And one more thing I would like to say, that is related to green card. This is in one card you can have the test series for all the examinations which are going to be there in the complete month. Okay guys, yes, so now we will be having a starting of the topics. I'm moving to the topic which we are going to start today, that is from governors. Yes, so as others are going to join, I am just reaching onto the slide, as these slides are for complete theory of machines. These I am going to share with you guys so that you can revise the part which we have already covered in the classes. So that also I will be sharing with you, don't worry about that. So guys, we are starting with the governors. Yes, it is about to come, don't worry guys. Yes, okay guys, so now let us start this wonderful topic, governors. And guys, when I am talking about governors, so first of all guys, I would like to tell you that when we are talking about the governors, why we required that governor. And guys, please like and share the session so that others can also join it. So first of all, let us see why governors were required. As you know guys, the double acting steam engine was something made by Sir James Watt, and Sir James Watt have made that engine. But the problem was when this engine was applied onto the locomotive, there was a problem with that engine. That guys, what happened basically, as you know, when we find out the efficiency curve, so when the efficiency curve was plotted, by taking efficiency on the y-axis and by taking my dear the speed on the x-axis, then this curve came like this. And when this curve came like this, it means efficiency was found to be maximum at some speed. And if you want to operate at the optimum efficiency or optimum range, this was said to be the optimum range, and in this range efficiency was found to be maximum. So Sir James Watt wanted to operate in this range only. Vishal, good evening. Vikas, good evening. Dinesh, good evening. Jay Kumar, Radhe Radhe dear. So actually Sir James Watt wanted to operate his engine into this range. But what happened, as some of the station was coming, as some of the peoples were adding to the locomotives, the load was increasing. And as the load was increasing, good evening Raju. So as the load was increasing, speed was reducing. And as the speed was reducing, my dear, efficiency was also reducing. Similarly guys, sometime it happened that when the peoples are going away, going out from the locomotive, then guys what happened? Because of that, my dear, load reduces and speed increases. Then when the speed increases, then also efficiency gets reduced. So guys, that's why we were getting efficiency to be maximum in this range. So Sir James Watt wanted to operate in that range. So that's why Sir James Watt wanted that efficiency should be more or less constant. Velocity should be more or less constant. So Sir James Watt was trying to get that constant velocity for the locomotive, so that he can get this maximum efficiency. So for getting that optimum efficiency, he wanted to operate the engine at some constant speed, and for that purpose he invented the device named as governor. And my dear, governor for the first time was given by Sir James Watt. So that's the reason Sir James Watt is said to be the father of this field as well. So he's known to be the godfather of this field, governor, as well. Okay guys, so for this governor field also Sir James Watt is known to be the godfather. And at the same time, I would like to say one more thing guys. When he have given this wonderful device which I am giving the name as governor, my dear, at that time I would like to say that basically governors, when they have given, guys, governors are said to be basically of two types, and one governor are said to be of centrifugal type of governor. One governors are said to be of centrifugal type of governor, and the second type of governor is said to be inertia governor. Second type of governor is said to be inertia governor. So my dear, when we are talking about the centrifugal type of governor, they are working on the principle of centrifugal force. They were working on the principle of centrifugal force. But when I say about inertia governor, it was working over the combination of centrifugal force plus inertia force. So my dear, inertia governor was working over a combination of centrifugal and inertia forces. So my dear, if that is the case, I would like to say, for the field of centrifugal governor, Sir James Watt is said to be the godfather. And my dear, inertia force was taking two forces. That's the reason, my dear, these type of governor are said to be more sensitive one. So these types of governor are said to be more sensitive one, because here two forces are coming. As their two forces are coming, that's why they are more sensitive and they are lesser sensitive. But the point is guys, in our syllabus only centrifugal governor is there. Akshay, good evening dear. So we need to study only the centrifugal governor. And guys, I would like to say governor is basically a customized device. It is not like that you will be going to the market and going to a shop and you will say give me a governor. No, governors are made on demand. They are designed as per the requirement. Kalam, yes, good evening dear. So guys, governors are made based on the requirement. They are not like available on the shop and you are going to purchase it. No, they are designed based on the requirement. Okay, so mind this thing. Okay, so guys, now we are going to start this topic into a great detail. Sir James Watt was a very big mathematician. You know, first phase they were mathematician only. So governors basically work. What is the work of governor? Governor is there, my dear, to control the fluctuations coming from outside the engine. When I am saying outside the engine, basically it is increase of load or decrease of load. Whenever the loads are going to be increased, my dear, obviously the power requirement is going to be more. So governor increases the fuel supply at that time. And whenever loads are going to be reduced, speed will automatically be increased. So at that instant, my dear, governor is just reducing the fuel supply, and because of that the speed automatically will become constant. So if you want to know basic applications of the governor, yes, Sushil, good evening dear, and yes, Prabharan, yes, good evening dear. So one more thing I would like to add here guys, when you are talking about the application of the governors, so my dear, the first application, yes, is there. The first application is there, my dear. First application is there for the governor in the generators. When we are talking about the generators, you know, we are using the generator for electricity purpose, and when electricity has gone, then generator you are using. And guys, generator always rotate at constant speed. whenever you are going to increase the load over the generator by adding on to the electrical devices, then my dear governor is present over the generator to increase the fuel supply, so that when the fuel supply is going to be increased, whenever the requirement is more, it can generate more power. If you are not going to provide more fuel, my dear, if governor is not there, then my dear, as the load is being increased, speed of the generator will reduce, and that speed is very much associated. The speed is very much associated with the voltage. Reduction of speed will result in reduction of voltage. Rishabh, good evening dear. Ramesh Mohan, hi dear. Sahal, yes, good evening and thanks. Okay, you're welcome guys. You're welcome Sahil. Yes. So now let us see guys, when we are talking about governor, the other application is in engine. In engine also, my dear, governors are there. But when we are talking about the engines, engine is the part of generator also, engine is the part of automobile also. So when we are talking about automobile, in automobile guys, whenever we are using governors, so in automobiles, whenever you are using governors, in automobiles, my dear, the governor when you are using, there the system is not fully governed system. The system are partially governed system. What do you mean by partially governed system, dear? When we are talking about the partially governed system, my dear, the meaning is like that. Basically, if we are going to make fully governed system in automobile, what will happen? Like you are running onto a highway, you want to increase the speed, but governor will try to retain your speed at a constant value. Let us say governor is trying to make your speed to 50 km per hour. On highway, you will try to make it 70, 80, 100. But guys, governor will take it back to 50. That you never want. And whenever you are running in a city which is very, very congested, you will try to reduce the speed to 20, 30 km per hour. But governor will take it to 50 because governor don't know other things. It has to maintain a constant speed at some given value. That's the reason, my dear, in automobile we do not make it fully governed system, but we make it partially governed system. What do you mean by partially governed system? So guys, their governor is going to help you. It will be maintaining the speed according to your requirement. No doubt it will be maintaining the fuel supply. It will be increasing fuel, decreasing fuel, but not according to its thinking. It will be working according to your requirement. Once you want higher speed, governor will work according to that. Once you are going with lesser speed, governor will work according to that. And yes guys, if you see in city like Delhi, where there are more accident chances are there, therefore the big trucks companies are providing, according to the government regulations, they are providing some governors which will not allow the driver to move above 45 km per hour. And after that speed, if a driver will try to go, then my dear, governor will cut the fuel supply. So that is what governors are doing. Yes dear, everywhere we are using governor wherever drivers are not there. In power plant shaft, governor is there. So wherever driver is not there to control the speed, we are using the governor. In automobile, driver is there, so governor is partially used. It is partially governed system, not fully governed system. So I have given you some wonderful application, dear, and you will never get that kind of application which I have given you. So guys, the function is to maintain a constant speed. The flywheel had a function to maintain a constant torque, and governor has a function to maintain a constant speed. Yes guys, so let us move further. My dear, now we are talking about the centrifugal governors. We are going to discuss this type of governor only. It is of two types. One is simple pendulum type, and in this only one governor comes, that is watt governor. The second is loaded type. When we are talking about loaded type, there is one is deadweight loaded type, other is spring controlled governor. So my dear, when you are using deadweight loaded type, they are of two types. One is Porter governor, other is Powell governor. And my dear, when you are talking about spring control governor, there is Hartnell governor, Harton governor, Wilson Hartnell, and Pickering. Pickering governor is used in gramophones. Yes guys, so this is the application of this. Now when we are talking about all these types of governor, we need not to discuss all of them. Dear, in our syllabus, we need to discuss only Watt governor, Porter governor, Powell governor, and Hartnell governor. Even I will say the major work when we are talking about the questions to be asked, it will be majorly coming from the characteristics of governor, not on the details over the governor. Yes. Okay. Yes. Very good, guys. So let us move to the very first type of governor. It is pendulum governor. Simple pendulum type, Watt governor. So guys, when we are talking about a what governor, in this governor there are four major things. First of all, I would like to say guys, basically there is basically a very big shaft, and that shaft is known as spindle. So a very big shaft is there, that is known as spindle, and the axis of spindle is said to be the axis of governor also. And my dear, on this spindle we are going to have a mitre gear, and my dear, mitre gears are provided because mitre gear have one thing wonderful. Basically they are the type of bevel gear only, and when these two gears which are bevel gear, they are similar in sizes and shape, then my dear, this set is said to be mitre gear. And the mitre gear is having one beauty, that in mitre gear set, driver and driven shaft are running at constant speed. So in mitre gear, driver and driven shaft are running at constant speed. So when they are running at constant speed, my dear, if engine shaft is running at omega, this spindle will also be running at omega. And my dear, if that is the case, if it is running at omega, we will be having guys, this speed of engine and speed of governor to be same, because we wanted the same feeling for the governor shaft which are there with the engine shaft. Because if they will be having the same feeling, it will be very easy to understand what kind of speeds we are expecting, what kind of changes we are expecting, because whatever the change on the engine speed will be there, the same change of speed will be there with governor. So the pain which the engine shaft will be feeling, the same pain will be felt by the governor shaft. That is the beauty, my dear. And if that is the case, now I would like to say that you will be having two arms here, and those arms will be also having some fly balls. They are some spherical balls which are known as fly balls, which are having some small mass m. And my dear, obviously when we are talking about this, these two are made to make it symmetrical, so that some balance should be there when we are talking about balancing. And as this is rotating with omega, if I am saying that this is at a radius of r, then my dear, obviously one centrifugal force will be acting over it as mr omega square. And my dear, the angle it is making here is said to be the theta angle. And my dear, when we are talking about this angle, obviously the same thing will be there on the right hand side. So when we are talking about this guys, obviously one weight will also be acting here, weight is W. And now these fly balls are going to be attached. With the help of a sleeve. But my dear, this sleeve is going to be massless. So whatever I am making here, it is a sleeve, but that sleeve is massless. Okay, so it is going to be massless. And my dear, when it is massless, it is massless. So my dear, keeping it massless was the biggest mistake done by Sir James Watt, and because of this mistake, this governor was found to be not of good time. Yes dear, they are at 90 degrees to each other. You are very much correct, Rishabh. So as I said, this was kept massless, and here the intention of Sir James Watt to keep it massless was not wrong. Intentions was very pure. Intentions was because the movement of this sleeve is going to be very, very important. It is going to govern everything. So Sir James Watt was thinking it should be light so that it can move very easily. But guys, this became the blunder for Sir James Watt, because this became the biggest mistake, because of which Sir James Watt governor was not capable to run over the higher speeds. It was fail at 70 rpm. So 60-70 rpm it become insensitive. So there is no use of that governor. But guys, the concept used in other governor which became the useful one, they were just from the Sir James Watt engine, some Sir James Watt governor only. So the concept was copied from Sir James Watt. Yes, some things were modified and they have made the working governors. So my dear, when I am talking about these type of governor, as I said, now this is basically what I have made is basically nothing but this is your yes sleeve, and my dear, this is known as massless sleeve. And my dear, then this sleeve basically is associated. This sleeve was associated with the bell crank lever. And my dear, how it was associated, I am telling you. If you want to see this sleeve was basically like that. Sleeve was basically like that. This was the sleeve, and with this roller there is some bell crank lever attached. Bell crank lever is a lever which is having a kind of structure, this one. And by this was further attached with the valve, and that valve was present in the cylinder. And whenever you are going to supply the steam here, the flow of steam is definitely, my dear, is taken care by this valve, because this valve when will be opened, the flow of steam will become more and more, and when it will be closed, the steam will flow at lesser amount, at lesser rate. So my dear, this is something known as sleeve. This is something known as sleeve, my dear. So this is sleeve, this is bell crank lever. So my dear, what happened when the engine speed is going to be increased? When the engine speed अच्छा, मेरी वीडियोस को ढूंढने में प्रॉब्लम होती है। अंकुर मेरे नाम से सर्च किया करो भाई, मिल जाएगी आपको, सर्च बाय माय नेम, है ना? यस, वेरी गुड ऋषभ, ओके फाइन। सो गाइस, जैसा मैंने कहा, एज आई सेड दैट व्हेन द इंजन इज रनिंग विद सम स्पीड ऑफ ओमेगा, लेट अस से लोड ऑन द इंजन इज गोइंग टू बी इंक्रीज्ड. When the load over the engine is going to be increased, the speed will get reduced, and when the speed of this will get reduced, the speed of the sleeve will get reduced, and because of that, this mr omega square will get reduced, and as mr omega square will get reduced, this mass will be having a tendency to come down, and as it will be coming down, my dear, this mass will also go down, and because of that, when it will be going down, my dear, when it will be going down, my dear, this will be going like this, because here it is, the bell crank lever is there. So this will be having this kind of condition, and valve will open, steam will go more and more into that, and when the steam will be going, my dear, speed will further increase, and it will be reaching to the optimum value whatever you are working at. But my dear, at the same time, when the load or engine is going to reduce, the speed will increase. Increase of speed will result in the movement of fly ball in the upside, and when they will be going up, my dear, this sleeve will also move up, and this bell crank lever will move like this, and the valve is going to be closed, and the fuel supply is going to be stopped. So these are the things which are going to happen at that time, my dear. So as I said, my dear, this angle is theta, and I would like to say, my dear, this is radius r, and height of the governor is measured from this. This is height. It is basically the height, and my dear, I would like to say one more thing. The height is basically nothing but the distance between this mass, this is the link, this is the arm. At this fly ball mass, they are making a turning pair. So wherever the turning pair between this arm and link is there, up to that this height is measured, and at that only the radius is measured. So radius and height of the governor are measured from the governor axis up to the turning pair between arm and link. And my dear, this angle, whatever it is going to be, it is said to be beta angle. So my dear, there are four parameters. One is r, other is h, other is L, theta, other is beta. It seems to be four parameter, my dear. But if you are going to change even a single parameter, all of the parameter will change. It says all the parameters are interconnected, my dear. So one more thing I would like to say, that we guys are having basically stoppers. One stopper is at the up position, one stopper is at down position. So this sleeve is going to move only within the range. And my dear, every position of the sleeve indicates some speed. So my dear, every position of the sleeve indicates some particular speed. Okay. Okay, very good, Venkatesh. Then it's fine. Okay, wonderful. चलिए बढ़ते आगे. Let's move further. So dear, as I said, my dear, when we are going to rotate it with the omega, the things I have told you, what is the working condition. So my dear, every position of the sleeve is obviously, my dear, it is connected to some of the position. So one position of the sleeve means one speed. So as the speed will change, position will change. So position is closely associated with the speed, guys, and it is said to be the performance. Rishabh, basically this channel is dedicated to English only, so I cannot use Hindi in this channel videos. If you want to learn in Hindi, you can join Mechanical Marvels. There, Gradeup GATE Mechanical Marvels, I am teaching in Hindi, so there you can attend that. Okay. Yes, Sahal, don't worry. This channel and everything going on this channel is dedicated to you guys who don't know Hindi. Okay. For Hindi peoples, you have two options. You can join here as well as you can join at Mechanical Marvels. So for Hindi people there are two options. For English people there is one option. But this is the previous channel, so here I cannot go into Hindi for sure. Yes, so don't worry guys. So English is comfortable for all of you, I know that. So guys, these are the things I wanted to tell you. So guys, these positions whenever we are talking about, they are very well designed basically, and based on that position only the governor is going to work. So sleeve cannot move beyond these two values. So my dear, these two positions are also corresponding to some speed. Let us say this is corresponding to some speed n1, it is corresponding to some speed n2. Then governor can govern the speed only between these two ranges. Governor cannot go beyond this n1 and n2. Neither it can go above n1 nor it can go below n2. So my dear, it will be working only in between this range. So that's why we have put stopper here, because other than this range governor cannot work. So mind it guys. Okay, this is the part when we are going to design the governor. And when we are talking about this what governor, so my dear, obviously when we are talking about the governor, there are three configurations possible for this type of governor. One is a simple pendulum type vote governor, and the line diagram for governors are made like this. This is the line diagram what we have made. This was the line diagram. So my dear, this is said to be simple pendulum type vote governor. Next I am coming on to open arm type. When you are talking about open arm type governor is like this. Open arm type governor is like this. Open arm type governor is like this. So here if you are going to see, this is going to be the hinge point for sure. And yes, radius is measured from here. Height is also measured from this hinge point only. So these are R and H. So my dear, this is said to be simple pendulum type. This is said to be simple pendulum type. This is said to be open arm type. And my dear, when we are talking about this open arm type, there is a crossed arm type also. When we talk about the crossed arm type is like this. When we are talking about crossed arm type, it is like this. This is crossed arm type. Okay guys, so this is radius, this is height. Okay, so this is open and closed arm type. Yes, fine. Okay guys, let us move further then. So these are the three categories, and we are going to analyze this simple pendulum type vote governor. Let us analyze this simple pendulum type vote governor. If you are talking about the simple pendulum type vote governor, my dear, this is going to be in this way. So when we are talking about the forces acting, this is basically a force mr omega square, and this is basically a force mg. And my dear, this angle is going to be theta for sure. And you know that if I am saying this is the tension acting in this arm, and if this is tension T, if you say the dynamic equilibrium for this fly ball, so my dear, there is a force acting mg here, and obviously there will be a force acting T, because you know that this is T. So you know that if this angle is theta, obviously this angle will be theta. So this is T cos theta and this is T sin theta. And if this is the case, you know this is mr omega square. So if you take horizontal and vertical equilibrium, you will be getting T cos theta to be equals to mg. This is I am going in a simple way. Otherwise dynamic equilibrium we need to take about the hinge point for all other types of governor. And my dear, at the same time you will be writing T sin theta is equals to mr omega square. Dividing 2 by 1, you will be getting tangent theta is going to be equals to, this is r omega square upon g. So my dear, when we are talking about this tan theta, if this is theta, this is height h, this is r, so you can write tan theta is r by h. So tan theta will become r by h, my dear, and it is equals to r. Omega is 2 pi n by 60 ka square divided by g. So from here r will get cancelled out, and you will be getting guys n square is equals to 895 divided by h. So when you are going to see 895 divided by h, my dear, when you are going to see this 895 divided by h, So my dear, this is known as the dynamic equilibrium equation for watt governor. You can put the value of speed, you will be getting the value of height. As I said that for every speed there is a position of the sleeve which is fixed, and that is said to be the performance. R is the radius, kalam kalam, R is the radius. So R is the radius, R is the radius, this is R radius. The distance from the governor axis up to the turning pair, my dear, up to the turning pair between this arm and this link. So my dear, this is something known as R. So I feel, well Murugan, you are clear about this? Yes guys, wonderful. Are you getting it or not? Please tell me. In case of any doubt, please ask. This is a wonderful topic we are learning. So guys, when we are talking about this is said to be the watt governor. And guys, you can see this 895 by H. You can also write this H to be equals to 895 divided by N square. You can see as this is N square term is coming here. So my dear, if you will be checking it, whenever the speed reaches to 60 rpm, after 60 rpm, my dear, the governor becomes insensitive. And my dear, when the governor will become insensitive, my dear, it simply means that when the governor will become insensitive, it simply means that after 60 rpm, when the speed of the engine will change, then my dear, governor will not be able to feel that change of speed. And as it is like this, it becomes insensitive. Like let us say you become insensitive to any touch. So some people are coming and they are slapping you, but you don't even feel that slap. Then my dear, you will not be taking action against that. Similar to that, my dear, this governor becomes insensitive after 60 rpm. And my dear, when it will become insensitive after 60 rpm, now whatever the changes of speed will take place, governor will not be able to feel that. And when the governor will not be feeling the change of speed, governor will not be taking any corrective action. So my dear, it will become useless after 60 rpm. And guys, basically when I was teaching that in class, I have proved that point also, that it becomes insensitive in the ranges after 60 rpm. But here we do not have so much time, because governor I teach in 4 to 6 hours. 6 hours I feel the minimum time, not 4, 6 to 8 hours. So when governor I take 6 to 8 hours, here I cannot have, because this is a revision time which is going on. So it will be wasting of time. Otherwise I can prove here this point. Some of the classroom students know that I have proved it. You can also check it just by putting two speeds. When you will be putting N to be 75 rpm and N to be 80 rpm. So putting these two speed, you will be checking the value of H. And do this for the same when you will be putting 50 rpm and 20 rpm. You will be feeling that for this 5 rpm change, you will be having tremendous movement of H, tremendous change of H, which will show the movement of sleeve. Here the H will be changing by very small amount. It means sleeve will not even move. And you know, movement of sleeve is something which results in the supply of fuel. So that's why I said this is how we can prove it. But now we do not have that much time to prove this kind of thing. Otherwise time will waste. This is how the governor is working. You can feel it. This is how here the bell crank lever is using and how valve are open and close. So this is the practical case you can see. But guys, this governor was useless, because at that time also the minimum speed of the engine present was 200 rpm. So we could not able to use this engine at that time. So now they are definitely useless. Okay. So this governor was never in use, because the minimum speed engine at that time was 200 rpm. So lesser than 200 rpm, this governor is going to fail. So it is of no use, my dear. That's why we are not using this type of governor. But this is the simplest form of the watt governor. We have seen the analysis, guys. Now we are coming to the dead weight loaded Porter governor. So when we are coming on to the dead weight type Porter governor, then my dear, about this governor there was nothing changed. Only one thing, dear, the sleeve was massless. In the watt governor, Sir Porter have taken a very big weight, and that very big weight he have kept over the sleeve. So my dear, because of that, this sleeve become very heavy, And when this was done by Sir Porter was knowing he is going to increase the inertia of the system, and he was knowing that after increasing the inertia, people will always say bad thing about him because he was going to increase the inertia. But guys, the problem was thanks Velmurugan, but before Sir Porter, the governor which was there was not a practical governor. This was the first governor which was capable of running in the engines. And guys, as this was the first governor, so the main point about this governor was that it was a working governor. So my dear, the main point was this was a working governor. That was the big thing. So guys, at that time, to make a working governor was the first requirement. Like nowadays, first of all, we are thinking that some COVID vaccine shall come. We are not thinking about the side effects of that vaccine, because first thing is to control the COVID-19. After that, we will make improvement over the vaccine for sure. So dear, at that time, the priority was to make a working governor. They felt, okay, we will improve upon it later. First of all, we shall go for the working governor. That's why people was not thinking much about that. And guys, definitely in the classes I have done the analysis of these types of governor. But I would like to tell you guys, those analyses are not important for GATE purpose. They are important for engineering services conventional purpose. So here I am directly giving the result, but if you want, I can do the derivation because I have everything here. I need not to go for looking at the notes for these things. Never, because this I have done all these things during my preparations only. So whenever you can say I can derive anything, whatever I am teaching you. But guys, it will be wastage of your time. I don't think you are also feeling that I shall go for these derivation. But if anybody of you want, I can go for the derivation. But the major point is it is not useful for you. In this chapter, you need only the characteristics of governor, which are isochronism, stability, sensitivity. These are the things on which the questions will be coming. Yes, hello. Yes, this is not even less important. This is, I will say, not important. So when I will be going for the derivation, for this you will be getting this type of result. You will be getting this type of result. Here n square you will be getting out to be equals to 895 divided by h, and this is going to be equals to, my dear, this is m plus m by 2 1 plus q divided by small m, and here q is nothing but tangent beta by tangent alpha, and tangent alpha is r by h, you know very well. And guys, when I am writing this, I am ignoring the friction present. Yes, otherwise if I am assuming here the friction is not present, and I would like to say that in examination also, when you will be having the question, you will be given like friction is not present. Okay, and if you are giving the friction is present, then definitely my dear, you will be using the friction also. But as I said, the friction will always be absent. They will never give you friction, otherwise you will be unable to solve it. Okay, yes, it will become very, very complicated. So this is the direct formula which you will be getting. And if you see this carefully, my dear, that previously we were having this term h is equals to 895 divided by n square. According to Sir Porter analysis, we have multiplied it with sum of the factor, and this factor should be more than 1. Otherwise, this was insensitive vote governor because of this big factor n square. So when you are multiplying with this factor should be much more than 1. Then only this governor will be able to work at the higher speed. So my dear, that's why Sir Porter, who was a very, very big mathematician, he kept, my dear, the numerator, this one, quite more than that of this denominator. And for that you can see this will be more than 1 only when the mass of sleeve will be very, very big as compared to the mass of fly ball. And I will say the minimum ratio of this to this was kept 5 to 10. So my dear, fly ball, if you are comparing with the sleeve was 5 to 10 times in weight. Sleeve was 5 to 10 times in weight than that of the fly ball. So my dear, sleeve was 5 to 10 times in weight than that of the fly ball. That was the thing, my dear, Sir Porter have done. And because of that, my dear, this governor became the first working governor. in the field of governor, and this is also a centrifugal type of governor. Then my dear, after that one governor came into picture, that is Powell governor. Sir Powell didn't touch this weight over the sleeve. Because of this weight over the sleeve, the governor was becoming the working governor. But what have been done by Sir Powell? Sir Powell have done one thing, that previously those fly balls were like this. He have made the fly ball like this. So this was something he has changed. So my dear, by doing this, what was happened? Definitely my dear, by using the fly balls like this, there were certain advantages. Then only he was using this, and because of those advantages, whatever the governor came after this, they were having the flywheel position like this only. They have never kept the fly ball like this. And my dear, when you will see the reason behind that, by putting the fly ball like this, whenever you will be doing the analysis of this governor, you will be finding out that if previously you were using the fly ball of 5 kg, now my dear, you can do the same work, you can get the same performances by using the fly ball of 3 kg. So my dear, by doing that, the mass of the fly ball is reduced. I am just saying that you can get the same performances. You can get the same performances by a lesser weight of fly ball. And my dear, when you are capable of getting that, then definitely my dear, we will be keeping the fly ball position to be this only. This can be proved again by the derivation, which is not required for you for the gate. Then why I am telling all these things? So that you have a small idea over it, so that if somebody is asking you in interview, you will be in a position to tell that. Okay. Otherwise guys, if you want to go about the derivation, my dear, definitely for 2022 we are starting a series, and I will be starting it from theory of machines only. In that class over YouTube, I will be deriving these things and properly will be deriving the reason behind all these things. Then I will be teaching governor for 8 to 10 hours. You can join that to know the exact reason behind that. But for gate examination, it is not at all required. So we are not going to waste time. But if you want, we can go for that. Akshay sir, in gear train, if ring gear has outer and inner gear, then how to apply tabular method? Find speed of outer ring, please. Sir, only that problem stuck. Akshay, do one thing. Whatever the question you are asking, just share the problem in the Telegram channel or onto my email ID. I will be personally share the solution with you, because that class is not related to that topic, so it will be not comfortable for other students if I will be going into that. So I have already given my email ID many times. Once again I am writing, if you are interested, you can share that problem to me. I will be sharing the solution to you, or in the Telegram also you can send it. Yes. You can note it down, you can take the screenshot of this. Okay, yes, fine guys. Yes, Ananya, hi dear. So as I said, this is something known as Powell governor. And my dear, when we are talking about the analysis, you will be doing the analysis by finding out the eye center. Here you will be getting the eye center of this. Why? Because you know the movement of sleeve is like this. Perpendicular to sleeve, this line will be coming. And you know fly ball movement is going to be like this. Perpendicular to fly ball will be this. So this will be the eye center of the mechanism. And about eye center, you will be taking the moment to be equals to 0. And when you will be taking the moment to be equals to 0, you will be getting, my dear, this kind of equation. You will be getting this kind of equation. Here you can see E is the distance of mass. C is basically this height. R is the distance of the turning pair. I already told you R is always the distance of the turning pair of the arm and the link. This R has nothing to do with the fly ball position. Mind it, in many good big authors textbook, they have made this mistake. They have made this mistake that they have taken R up to this one. Dear, this is not R. R is always the distance up to this turning pair. This is R dash basically. Okay guys. So R is always considered from the governor axis up to the turning pair between the arm and the link. Mind this thing always. But yes, in objective they have till date never asked a single question on governor, and they will be asking only from the characteristic. They will not be asking from this I can guarantee you, because otherwise the question will be very lengthy and it will require 5 to 7 minutes to solve. Better than that, it is better to go for other question, because we are allotted 2 to 2.5 minutes on the topic, on the question, not 5 to 7 minutes. Yes. So guys, this is something, the Pro-L governor. And my dear, when we are talking about the Pro-L governor, the advantage is that in Pro-L governor you can work with, a lesser weight of fly ball. That is the advantage. Okay, Akshay, fine dear. So now guys, we are moving with the spring control Hartnell governor. So dear, the point was, obviously, when we were talking about the mass of sleeve was 5 to 10 times more than that of the fly ball. So my dear, the problem was not the mass of fly ball, problem was the mass of sleeve. And my dear, fly ball was already lesser weight, and Sir Pro-L have reduced the weight of fly ball, but we wanted to reduce the major inertia which was with the sleeve. So to reduce that inertia, Sir Hartnell tried to think what is the purpose of that weight. And my dear, Sir Hartnell is said to be the second godfather of this field of centrifugal governor, because he came to know, my dear. And guys, please like, share this session to your friends also, so that they can also be benefited. These are the topics generally are skipped everywhere, so I am telling only the important topics for sure, obviously, because in 1 to 2 hours I cannot teach you 3 topics otherwise. But yes guys, I am giving you the idea for attempting the objective question from GATE and ESE. This I can guarantee. Once you will be learning the characteristic of governor, every question will be there from those topics only. You will not be getting any complicated question from that, because these are the newly added topic, and till now question have not been asked from this topic. So we are going in a manner so that we can just revising the basic things. Yes guys, so when we are talking about the spring controlled governor, so dear, Hartnell have found that whenever Hartnell was using the thinking about the why the spring is required. So guys, what he came to know, he said that basically the sleeve weight is doing only one thing. Sleeve weight is acting in downward direction. So sleeve weight is only doing one thing, that it is giving a component of force in the downward direction. So Sir Hartnell thought that work can be done by a compressed spring also. So what Hartnell have done? Hartnell basically replaced the weight and put in a spring there, because he was knowing that if he will be applying a compressed spring here, compressed spring will also be giving a downward force which was given by the weight of sleeve. So my dear, he have reduced the weight of sleeve. Let us say previously we were using a sleeve of 40 kg. He have reduced the 40 kg sleeve to 2 kg sleeve. So sleeve was reduced in weight, and in place of that he have used the compressed spring. And my dear, compressed spring will also be applying a force in downward direction. So the same work will be done by this, and if the same work will be done by this, my dear, now what will happen when the speed of the engine will increase because of reduce in load? Fly balls will go outward, and when the fly balls will go outward, obviously the sleeve will be going upside. And my dear, because of that the valve will be closing, and fuel supply will be reduced. At the same time, when speed is reduced, these fly balls will be going inside, and because of that the sleeve will be going downward, and valve will be open for the fuel supply. This is how the Hartnell governor will be working. And my dear, when we are talking about this Hartnell governor, obviously this is a bell crank lever. So this is a point of hinge. So my dear, in every condition you can take the moment about this hinge, because taking the moment about the hinge will give you the summation moment to be equals to 0. If you see this, you can see this, my dear, here mg force is acting in downward direction. And when you're talking about this, when you're talking about these two conditions, my dear, you can see basically if you are taking the mass in this position, because of the reduction of speed, mg will be acting downward and force will be acting here. So you can take the moment about this point. This is the mg, and this is the friction force and spring force. This is Fs spring force, this is the friction force. Let us say this is Fs1, this is Fs2. So you can take the summation moment about A. As I said, these types of question cannot come in the paper. Otherwise, there are 6 factor. They cannot make an objective question over that. But still, I am telling you how to take moment about that. So you can see, when you are going to see this force mr omega square, this is at a distance of A1. So I am saying that equation will be mr 1 omega 1 square into A1. and you can see this is creating a couple which is anti-clockwise. So I will be taking minus sign here, and at the same time you can see mg is also creating the same direction or opposite. It is creating opposite direction clockwise. So I will be writing plus mg into c1, and at the same time you can see this is also creating the clockwise. So I will be writing plus mg plus fs1, because spring force will be always acting downward, and this is going to be plus minus f. Friction may be upward, may be downward, depending on the sense that where the mass is going to be. And we have written 2 here because one part is this, other part is this. Total mass is dividing into these 2 parts. So guys, this you will be equating it to 0. Similarly, you will be making second equation for second position when the flywheel will be going outward. And when you will be having these 2 equations, you can find out whatever the unknown is. But guys, this type of question you cannot expect in the paper, because they are going to be very lengthy. And guys, I will not suggest you to attend this kind of question, because they will be time taking. You shall go for this type of question at the end. I would recommend this. And guys, to simplify the question, later on they will be giving you, like I am just equating this, I am just writing this. For the second condition, when you will be writing, as the mass is going outward, this time mr omega and this both the forces will create the same direction. So this time you will be writing minus mr2 omega 2 square into a2, then minus mg c2, and plus mg plus fs2 plus minus f divided by 2 is equals to 0. And my dear, you can see there are 2 equations, there are many unknowns, and obviously this is acting at a distance of b1. So I must write that distance also. So my dear, when you are talking about this time, it will become b2. So you can see there are 2 equations, and my dear, to simplify this in the exam, even in conventional, we assume a1 barabar a2 barabar a, we assume b1 barabar b2 barabar b, C1 barabar C2 barabar 0, because my dear, when A1 will become A, B2 will become B, when they will become equal, then my dear, this mass will be coming in this position, and at this position mg will be acting in this direction from the hinge point. So the moment of mg will become 0. So that's why I said that this C1 and C2 will become 0. Analysis become very simple, and then you have to solve it. This kind of question always have been asked in conventional, never came into objective. So you can leave this thing, and I will suggest you to leave because the time is less. Those who have not attended these calculations in the classes, it is better to leave them. Otherwise, I have told you, you can go with that, but it is not required for paper. So I am suggesting because they are not going to come in paper. Otherwise, yes, I have taught you because it is in syllabus. Yes, Hari Shri. Sir, are there any handwritten notes for Tom? If yes, please share. Okay dear, I have given you email ID. You can mail me there. I will be helping you in that. Let us move further. Yes dear. Now we are talking about characteristics of governor. They are very important for gate. They are very important for gate. And questions will be coming from this only. Questions will be coming from this only, guys. First of all, I am telling about the stability of governor. So guys, when we are talking about the stability of governor, stability means stable equilibrium. Stability means stable equilibrium. My dear, stable equilibrium means what? Like, you know, if you are going to have a position of ball like this, if you are going to move this ball here, this ball will be coming back by its own. You need not to apply something. And if it is coming by its own onto this position, it is said to be stable equilibrium. So my dear, what do you mean by stable equilibrium? Let us say a governor is running. You are just touching a sleeve. Dear Navya, if I tell you truth, till this date, no question have been asked from governor in gate. In gate, the governor was added in 2016, and from that date till this date, there is no question asked from governor. Yes, next topic is cam we are going to discuss. There the questions are coming. From cams and gyroscope questions are coming. From governors questions are not coming. But don't worry, we are only left with 10 minutes for governor. Next 1 hour will be for cams and gyroscope, from where the questions are coming. So just 10 more minutes you need to bear this topic. After that, cams and governor, from there questions are coming every year. So this topic is not important at all if we talk about the previous years. But yes, I will not say that question will not come, but it will come from this topic, properties. So next 10 minutes are very important. Yes guys, always I will say hope for the best, prepare for the worst. So guys, once let us say what is the stability of governor. So if governor is following this condition, it is stable. What do you mean by that? Let us say guys, a sleeve is moving and you are having the fly balls to be working like that. If you are just sleeve is there at some position, you know sleeve is there for one speed, you just taking the sleeve up, you are changing the position of sleeve by your hand. And when you are changing the position of sleeve, if sleeve comes to its original position by its own, it means it is in stable equilibrium. It means governor is stable. So dear, when you are touching the sleeve and making it to move in either upward or downward, and my dear, after giving the motion upward or downward, if the sleeve is coming back to its original position by its own, it is said to be stable equilibrium. And my dear, this condition achieves when on increasing the R, speed will increase. When on decreasing the R, speed will decrease. This is the condition when governor is found to be stable. And my dear, this is the most desirable condition. If on increasing the R, speed is going to reduce. If on decreasing the R, speed is going to increase. This is going to be the condition of instability. And my dear, at the same time, on increasing the R, on decreasing the R, if governor speed is not going to change, this is said to be neutral equilibrium. And my dear, this neutral equilibrium position is also said to be isochronism. This is said to be isochronism, and this is the ideal governor, because we always want speed shall not change. Speed shall not change with the change of position of the sleeve. So my dear, this is what we require. Yes, and I will be telling you about this theoretical governor, and this is going to be the most important for your examination. So they can ask you which of the condition is true for stability. So for stability, R and N should increase and decrease simultaneously. This is the stability of governor. My dear, next is sensitivity of the governor. First of all, I would like to say we want governors to be more stable as well as sensitive. When we are talking about sensitive, guys, sensitivity is a property which we want that it should be with governor, but up to a certain limit. Like guys, let us say you are sitting. If you are sitting, someone is coming and he is slapping you, and after getting slapped, you are not going to give any reaction. So in that condition, I will say you are not giving any reaction. So I will say you are insensitive. But guys, in the other case, let us say you are sitting and some person is just going to touch you, and you are going to have a fight with him by saying you have slapped me. So this is the condition of oversensitivity. Both the conditions are bad, because if you are more sensitive, you will be having the problem with the peoples. If you have less sensitivity, then also you will be having the problem. So guys, both are undesirable. We want sensitivity up to a desired range. It means whenever someone is going to slap, you must take it as slap. Whenever someone is touched by mistake, you take it lightly. So guys, always sensitivity is required up to certain range. Like you might have seen some people are going to doctor, they are saying, sir, I am very sensitive, and that's why after every 15 days as the weather is changes, I am having cold and fever. So doctor will say you are more sensitive. Some people are saying my skin is very sensitive with the sun radiations. So my dear, sensitivity shall not be there over a range, above a range, because otherwise it becomes a very big problem. So guys, please like, share and subscribe this session if you have not done till now, because every day we are coming with wonderful sessions on this channel for you guys. And when you will be joining in a big number, it will be good for all of us, because more students with more content, more videos, more series, more sessions for all of you. Yes guys, so when we are coming about the sensitivity, what is the sensitivity? So dear, when we are talking about governor, how it is working, governor is moving the sleeve, governor is giving the sleeve movement to move the valve. So for valve movement, governor just give the movement to the sleeve. And my dear, the sleeve movement is the indication The sleeve movement is the indication of the governor or working of the governor. So dear, if I am saying, let us say speed is going to be changed from N1 to N2. So when the speed is going to be changed from N1 to N2, then I would like to say, let us say, if for less delta n, sleeve movement is more. I will say governor is more sensitive. Let us say we are having two governors, governor 1 and governor 2. So I am saying, guys, we are having two governors, and let us say the movement of sleeve was 5 mm and movement of sleeve was 5 mm. For the same sleeve movement, this governor was having a change of speed of 10 rpm and this governor was having a change of speed of 20 rpm. Then my dear, I will say this governor is more sensitive. So I will say sensitivity is inversely proportional to delta n. So my dear, sensitivity is defined as mean rpm to the change of rpm. So my dear, more the change of speed for the given sleeve movement, my dear, lesser will be the sensitivity. Or in other words, I can say, let us say we are having two governors, governor 3 and governor 4. Let us say, my dear, we are having these two governors, and I am saying that for these two governors, let us say for these two governors, we are having a delta n of 10 rpm for both of them. When we are having delta n of 10 rpm for both of them, and let us say here you are having sleeve movement of 2 mm and here you are having sleeve movement of 7 mm. So my dear, I will say that here sleeve movement is more. So this governor is going to be more sensitive. So my dear, here sensitivity is related to the sleeve movement. So my dear, I will say the sensitivity of governor is more. So my dear, there are two conditions. If you are taking the same sleeve movement, the governor with less change of speed is more sensitive. If you are having same delta n value, the governor with more movement is said to be more sensitive. This is how the sensitivity of governor is said to be. My dear, we have seen stability as well as sensitivity. So both are desirable property, but sensitivity should be in some range. Third is isochronous governor. So my dear, isochronous governor are those for which, my dear, delta n is 0. If delta n is 0, I will say sensitivity is infinity. And my dear, I would like to say sensitivity and stability are the opposite properties, because sensitivity means even a very small change of speed cause a very big movement of sleeve, and stability says that sleeve shall not move from a given position. So both are opposite to each other. So if sensitivity is infinity, my dear, I will say stability is 0. That's why I said this is the condition of neutral equilibrium. And my dear, if you want to learn these type of governor, they are very easy to understand but very complicated to make. Even they are impossible to make. We cannot make an isochronous governor. What is the reason behind that? Guys, I want to ask you guys, have you ever seen, just give me a minute. Yes. So guys, I would like to say, have you ever seen the crime patrol? If you have seen the crime patrol, what is going on there in the crime patrol? In the crime patrol, my dear, you have seen somebody is going to make some crime, and once the crime is going to be there, police is going to catch the person who have done that crime. Yes, Vaishnavi, hello. Then police is going to catch that person who have done the crime, and police is going to punish him. But guys, what if police is not allow the crime to be done, and before that crime is to be done, police is going to catch that person? It will be the great thing, no? So the same thing is isochronism. Just feel it, that governor is having some special power, and governor is capable of knowing what are the things going to be happen in the future. Let us say governor came to know after next 10 seconds the load on the engine is going to increase. So my dear, as the governor will be knowing this fact, what he will be doing? He will be opening the valve, and for opening of valve he will be changing the sleeve position. So he will be changing the sleeve position, because of which valve will open, and as the load is going to increase at that instant, if my dear governor is going to increase the fuel supply, you will not be able to see any change of speed, because my dear, for that purpose already governor have increased the fuel supply. So whatever the fuel supply is there for that speed, for that load, it has already been provided. So you will not be able to see any change of speed. But guys, to make this, sleeve has already moved. So sleeve will be moving, but speed will not be changing. So it means my dear, R will change, but N will remain constant. Obviously this is a hypothetical condition, because police cannot catch the person, the criminal, without the crime has to be done. So until the crime is not been done, police cannot catch him. In the similar way, as the speed has not been changed, governor cannot work. But guys, this is a hypothetical ideal condition what we are assuming here. Please tell me guys, did you get isochronism or not? So isochronism means whenever you came to know that yes, speed is about to change, load is about to change, you will be acting before that change is actually happen, and you will not allow that change to happen. This is a very complicated situation. We cannot make isochronous governor, because friction is present always, and until the friction is present, nobody can make isochronous governor. Once the friction is not there, then it is possible to make isochronous governor, but friction can never be zero, you know that fact. So guys, basically what isochronous governor is doing, everything in zero time. Means in isochronous governor, for the change to become, governor is acting in the zero time. That's why this governor is not possible. Sir, governor is used in CI. Dear, governors are used for supplying the fuel in every engine. Basically, flywheel and governors are always present in all the engines. Without flywheel, engine cannot run. But governors may be partially, may be fully attached with the engines. Somewhere they are partially governed, somewhere they are fully governed. But where drivers are there we are not using governors. Where drivers are not there we are using the governors. So in automobiles, governors are acting as a partial governor system. I already explained these things in the starting of the class. If you have missed that animation, you can see that part. Okay. So let us move further, guys. This is isochronous governor. Now we are moving to the hunting, my dear. So hunting is the stage of oversensitivity, my dear. Hunting is the stage of oversensitivity. My dear, if the governor is oversensitive, then we are saying it is to be hunting. How it is going to be happen? You know, as the load is changing, because of change of load over the engine, the speed of engine is changing. And as the speed of engine will change, my dear, the movement of sleeve will happen to increase or decrease the fuel supply. But let us say governor is going to be more sensitive. Then what will happen? My dear, for a very small change of speed, governor will give a more movement of sleeve. So if governor is going to give you more movement of sleeve, that more movement of sleeve, my dear, obviously will be changing. Let us say I am saying the speed is going to be changed by 5 rpm, and corresponding to that change, sleeve need to move by 2 mm. But my dear, as the governor is oversensitive, sleeve movement is not 2 mm, it is going to be 5 mm. So my dear, let us say speed was initially 200 rpm, and by increasing it becomes 205 rpm. So to reduce it to 200 rpm, the movement required was 2 mm. But sleeve movement went to 5 mm, so my dear, reduction will be going to be 190 rpm. So previously the change was of 5 rpm, now the change is of 10 rpm. So my dear, because of this 10 rpm, not basically 10 rpm but the 15 rpm. So for this much change, my dear, once again now sleeve will think, okay, there is a change of 15 rpm. My dear, so for that 15 rpm change, the sleeve movement required is 6 mm. but my dear governor is going to give it to 15 mm. So because of that, whenever this has to come to 205, it will go to 235. So my dear, you can see the change is continuously increasing. Then once again, whatever the movement is required, governor is going to give more sleeve movement to 25 mm. And slowly, my dear, initially the sleeve has moved to this much distance. The movement will be increasing and finally it will be reaching to the stoppers. And now it will be moving between the stoppers and there will be a lot of vibrations and noise coming in the system because of the vibrations of the sleeve. And my dear, this is going to be the oversensitivity and it is said to be the hunting of governor. We never want this kind of situation to happen. This is the bad situation. This is the situation we never want to happen. We always want to avoid that situation. Hunting is not a desirable thing. Yes, wonderful guys. Okay guys, so now we are coming to the cams. My dear. So all the important things I have discussed in the governor. Otherwise, obviously, they are big topics of 6, 8 to 10 hours. We cannot complete it, but we can discuss the important part of that as we are doing in all the subjects in this qualifier series. The purpose is to make you give some good marks. When we are talking about cam, my dear, cam is a mechanical element which drives another element known as follower, and my dear, it is done by the direct contact. So in cam and follower, this is the only higher pair mechanism which is there in your syllabus. My dear, one thing is direct contact is must here. Second thing is cam is going to drive the follower. So in this mechanism, cam is very powerful. Cam is going to govern the motion of follower, and follower is not a powerful person. Follower is not even run by its own. It is running by the cam. So my dear, that's why I said in this mechanism, follower has no values. Everything is cam only. If somebody asks me the motion of follower, I will say only cam can tell you. No other body can tell you the motion of follower. So my dear, it is a wonderful situation when cam is transmitting the motion to the follower by the direct contact. And my dear, when we are talking about cam and follower, there are basically three parts. One is cam, other is follower, and my dear, there is third element which is known as frame. Here there will be a spring which is going to maintain the contact between cam and follower. So my dear, generally students have a doubt. They feel that cam is always a rotating element, but my dear, it is not correct. Cam may be rotating, cam may be reciprocating also. Follower may not always be reciprocating, follower may be rotating also. You may have this kind of condition also when cam is also rotating and my dear, follower is also having some partial rotations like this. Even you can have a condition, my dear, when cam is a reciprocating thing and my dear, follower is a rotating thing. So my dear, all the possibilities are always there with us. Cam can rotate, reciprocate, follower can rotate, reciprocate. Okay guys, so anything can happen. Whatever you feel, everything is possible. So guys, whenever we are talking about cam and follower, there is a direct contact required. Now we are coming to the classification of cam. So my dear, the very first type of cam I will be telling you is a wedge cam. When we are talking about wedge cam, my dear, in wedge cam, this is the cam basically. I will be showing you the animation of all. This is the wedge cam, and if you are having a follower like this, you can feel one thing, as the cam will be reciprocating like this, follower will be reciprocating like this. This is the line of motion of cam, this is the line of motion of follower, both are perpendicular to each other. Second type of cam is radial or disc cam. Here this is a cam, my dear, and as the cam will be rotating, follower will be reciprocating like this. Okay, so there if you see, the rotation cam axis is this and follower motion is this, both are perpendicular to each other. Yes, next my dear, we are talking, this is the kind of cam we have just seen, this is the working. Now we are coming to cylindrical cam. My dear, in this cylindrical cam, this cam will be rotating like this, follower will be reciprocating like this. If you want to see the exact working, this is the working, this is the cylindrical cam. You can see that cam is rotating and follower is reciprocating like this. Okay, so this type of, yes, here also you can see cam is rotating like this, follower is reciprocating like this. So this is known as barrel cam or cylindrical cam. So these are the animations of the cylindrical cam. Guys, please tell me, are you getting it or not? These are the topics nobody teaches. So we are doing these topics as per the requirement of GATE. Hope you guys are getting in a wonderful manner. So next, let us see wedge cam. We have already seen. This is the wedge cam animation. You can see the wedge cam is reciprocating here. Follower is reciprocating like this. We are also having a flat plate type of cam. In flat plate type of cam, there is a groove there, and in this groove, this is a follower. So you can see, guys, whenever we are talking, this cam will be reciprocating like this, follower will be reciprocating like this. So this is how the things are going to be. Yes, wonderful, Imran. Fine dear Vikas, Animesh, Navya. Fine Animesh. Okay, guys. So let us move to the next. Now we are talking about the second type of cam based on the follower movement. You know that, my dear, whenever the cam is going on, there are three types of things occur. One is rise, other is return, the third thing is dwell period. So whenever the follower is going to go up, it is said to be rise. Whenever it is coming back, it is said to be return. And my dear, if it is holding for some time, it is said to be dwell period. So when we are talking about rise return cam, if you are going to make a diagram between x and theta, x is the displacement of follower, theta is the angle of rotation of cam. So when you will be making the very first type, you will be having rise return cam. There will be a rise, there will be a return. So this is said to be RR cam. Second is my dear DRR cam. Here you will be having dwell, rise and return. So when the follower is not moving, it is said to be dwell period. When the follower is not moving, it is said to be dwell period. So my dear, this is dwell, this is dwell, this is rise, this is return. So this is DRR type of cam. And my dear, then the next type of cam is RDR cam. Here if you are going to make, first of all, my dear, there is a rise, then dwell, then return. So this is said to be RDR type of cam. Then it is DRDR type of cam. This is DRDR type of cam. In this, my dear, first of all, there will be a dwell period, then R, then dwell, then return. I would like to say, guys, there are only possibilities of these four types of cam. Yes, thanks Vikas. So my dear, these are all the four types of cam. I would like to say there is no other type of cam according to follower motion. You can, whatever the other kind of motion you can make, dear, that will be one of these four only. You can see that. And guys, these are the four types of motion. And I would like to say, whenever you are talking about this, as you can see, whenever the follower is going rise, up it is rise, coming back is return. And my dear, whenever the follower is not having any motion, that is dwell period. So you can see, if we are having this kind of cam here, from this to this, the motion is not there. And if this is the cam center, my dear, up to the distance, when the distance of cam and follower remains the same, so up to this, follower do not move. The follower is moving in this portion when the radius is continuous changing. So when the distance of cam profile from the center of cam is constant, for that condition, my dear, there is no motion of follower and it is said to be the dwell period. So it is said to be the dwell period. It is said to be the dwell period. It is said to be the dwell period. And my dear, if you see, this is the rise, this is dwell, this is return. So dwell means there is no motion of follower. So my dear, this kind of curve can be made. Now guys, when we are going to say there is a theta, angle of rotation of cam, there are many things you can define. There is one angle is known as outstroke angle. Outstroke angle. Then second is return stroke angle. Third is dwell angle. And fourth is angle of action of cam. I am telling you what are these four. When we are talking about outstroke angle, when the follower is going to rise, At that time, whatever the cam rotation is there, it is said to be out stroke angle. When the follower is returning back, at that time whatever the rotation of crank is, rotation of cam is there, it is said to be return stroke angle. And my dear, the position up to when the follower is not moving, it is said to be dwell angle. And my dear, from the starting of rise to the end of return, whatever the angle is travelled by the cam, it is said to be angle of action of cam. And angle of action of cam is always lesser than or equals to 2 pi. It is always starting from rise to the end of return. If some dwell period is coming in between, it is counted. But if some dwell period is coming before rise or after return, it is not counted. Mind this thing. Like we have seen 4 types of motion previously. If you ask me here, from starting of rise to the return of, from starting of rise to the end of return, total angle is going to be 2 pi. Then angle of action of cam is 2 pi. But my dear, here, starting of rise is this. Ending of return is this. So only this angle is the angle of action of cam. It is less than 2 pi for sure. It is less than 2 pi for sure. So my dear, these are the angles of the cam. And now we are coming on to the types of follower. The very first type is knife edge follower. Knife edge follower is like this. My dear, this kind of follower is very, very dangerous. Whenever it is coming in contact with the cam, my dear, if you want to feel this condition, you can see one thing, that as this is the point of contact, and at that point this cam is rotating but follower is fixed. So there is a relative motion at this point. So the friction present is the dynamic or kinetic friction. Kinetic friction is always more than 0. It can never be 0, and it is the maximum value of friction. So if it is rotating like this, so on the follower, friction will be acting in this direction, and this is going to be the maximum value mu k times of normal reaction. This is the maximum value of friction. So my dear, when we are saying this is the maximum value of friction, the point is, guys, yes, Sajid, hello dear. So this is the point which is very, very small area. Here this area is nearly equals to 0 for this point, as this point is a sharp point. So this area is nearly equals to 0. So my dear, if I am saying area is nearly equals to 0, I don't want to say the friction will be more, because friction is independent of area. But guys, I would like to say here the point is less, friction is more. Because of that, the wear will be more. The condition is similar to you are taking a knife and you are putting on your hand, keeping the cam, keeping the hand to be a cam, and you are rotating your hand as cam is rotating. My dear, within 5 minutes you have to go to hospital, because this knife edge follower is going to cut your hand. My dear, that's the same thing. This knife edge follower is going to crack the cam, is going to fracture the cam just after 5 to 10 minutes. And the life of this type of motion, this type of mechanism is very, very less. You cannot use it practically in much of the application. Okay, so guys, that is the major issue with this type of mechanism. So when we are talking about knife edge follower, life is very less, we never use it. Now the roller follower. In roller follower, the motion is pure rolling, and because of that, at this point friction is static. And you know, static friction can be anything from 0 to mu n. So basically it is having some lower value, because there is no contact, no motion at the point of contact. So the friction is static, and when the friction is static, my dear, friction is lesser, so wear is going to be less. Dear Animesh, then also you cannot increase the life much, then also the life remains lesser only. And when you are talking for the roller follower, it is having a life which is more than a human life. So it is better to use this type of cam follower. So my dear, when the best type is available, why you will go by that? Up to which level you are going to laminate? It will be wear out soon, as whatever the animation you are using. It can increase the life slightly, not permanently. But using roller follower can increase the life permanently, and the life is more than the human being life. So you can use it for longer. And my dear, these type of follower have only one disadvantage, that they require 3D space. So they were used in big aircraft and gas engine at that time. But nowadays we are using these type of follower in IC engines also. But previously we were not using them, because they require 3D space, and at that time engine was not modified to have that kind of follower. So guys, please like and share the session with your friends, so that they can also benefit it from this. Next is flat face follower. So my dear, when you are using this to be a cam, we are using this to be a flat face follower like this. And when you are using this flat face follower, my dear, this time the contact area is slightly more than the sharp point of knife edge follower. Because of that, it is better than the knife edge follower, but it is still not better as compared to the spherical follower. Spherical follower or roller follower, not spherical, roller follower. Roller follower are the best type of follower we got till now. And my dear, here the problem comes is related to the surface cracks. So surface crack are coming here. And my dear, because of that, these type of follower are used, but my dear, they also fail after 2 to 2.5 months, and after that they needs to be changed. And my dear, then you can also use a spherical face base follower. Spherical face follower is like this. Spherical face follower is like this. These type of followers are better than the flat face follower, and at that time they were used in IC engines, but nowadays they are not used in IC engines. Nowadays you can use the roller follower also. Yes guys, please tell me, are you getting it or not? These are the cams and follower classifications. This is, my dear, the radial follower and the offset follower. If you are having a cam like this, and this is the center of rotation of cam, if the axis of follower is passing from this, it is radial follower. But if the axis is not passing from this, if follower is somewhere here and these axes are not matching, there is an offset, then it is offset follower. By providing the offset, my dear, the force required to move the follower is getting reduced, but the stroke length of follower is getting reduced. So there are advantages as well as disadvantages. Santosh, if it is a point contact, how come surface crack? Dear, because when you are going to compare the point with the microscope, then the point which is present over the flat face follower is 1000 times bigger than that of the point which is coming over the knife edge follower. So microscopic view will give you that that point is also 1000 times bigger than the smaller point coming in the knife edge follower. So my dear, surface stresses are induced. I will not say surface crack, but surface stresses are coming because that contact is slightly bigger than the knife edge type of follower. So you will be getting some kind of surface stresses. Rather than surface crack, I will say surface stresses. Crack will come once that stress is going to exceed the strength of the material. So crack is the next step which may come, may not come. But surface stresses for sure will be induced. And guys, flat face follower is also known as mushroom type of follower. Mind this thing. Okay guys, now we are moving further. So dear, now we are going to see the nomenclature. So when we are talking this is a cam, this is a follower. Then my dear, when we are saying this is a follower, okay, for nomenclature, rather than showing it into this figure, I am showing you my own figure. Let us say this is a cam. Okay, and my dear, this is a follower. So if you want to see the nomenclature, first of all, try to understand. My dear, I started making a circle. This is a circle with center as cam center. This was the second circle I plotted. The third circle I plotted was tangent to the cam profile. This circle was tangent to the cam profile. After that, whatever the circle I will be plotting will be cutting the cam at 2 points. So this circle which is tangent to cam profile is said to be base circle. And my dear, this base circle is very important parameter. This indicates the size of cam. My dear, now as you know that if you see the follower motion and if you make the locus of this point is said to be trace point. If I fix the cam and allow this follower to move, then my dear, follower will traces this path. Trace point will traces this path. And my dear, this path is known as pitch curve. This is known as pitch curve. My dear, if I am going to make a circle taking cam center as center and it is tangent to pitch curve, it is said to be prime circle. It is said to be prime circle. So prime circle and base circle are similar thing. I will say the radius of prime circle is the radius of base circle plus the radius of roller. Okay, this is the relation between radius of prime circle and the radius of base circle. And my dear, I would like to say one more important thing. Navya, this session will go up to around 1 p.m. or 1:15 because we are going to complete today. This is the last session of Tom, that's why it is slightly lengthy. Otherwise, the session was going for 1.5 hours. But this is the last topic, so we will be completing it today anyhow. So guys, when we are talking about the next thing, if you are talking about this to be a cam, and my dear, let us say we are having this to be a follower. So you know that if you are going to say direction of follower velocity will be this. The direction of follower velocity will be this. And if I plot a perpendicular to both follower and cam profile, it is this. This is perpendicular to both the profile. The angle between these two is said to be the pressure angle. This is said to be the pressure angle. Okay guys, it is said to be the pressure angle. And corresponding to this pressure angle, if we say pressure angle is a variable. During the motion it increases, during the motion it decreases. And when this pressure angle is going to be maximum, for that maximum pressure angle, whatever the points P1 and P2 or maybe more than these points are there, whatever the points which are cutting this pitch curve, let us say there is a point P1, there is a point P2, whatever the number of points for which phi is maximum, those points are said to be pitch point. Those points are said to be pitch point. And if you take the distance from center to pitch point as radius and plot a circle, then this circle is said to be pitch circle. My dear, for any cam there is only one pitch circle. Pitch point may be 2, pitch point may be 4, pitch point may be anything. Pitch point may be anything, my dear, pitch point may be anything, but pitch circle is only one. Very good question, Sahal. You are saying what is circle 1 and circle 2? Dear, I tried for making a circle which is going to be tangent. This circle is nothing. This circle is also nothing. But this circle becomes the tangent. This becomes the base circle. Other two circles are nothing. The circle which is tangent to cam profile is the base circle. The circle which is tangent to the pitch curve is the prime circle. Other circle are nothing. But yes, one circle which is made by taking the distance from pitch point and center as radius, plotting a circle, that circle is the pitch circle. So I have taken too many circles, hope you are getting it. And with this we have completed the terminologies of cam. Now we are coming to the follower motion, the last part of cam. Then we will be entering into the last topic, that is nothing but the gyroscope. Okay guys, let us move further. Hope you guys are getting in a wonderful manner. So guys, next is something related to follower derivative. My dear, when we are talking about the follower derivative, you know that derivative means like dy by dx. The derivative is dy by dx. So my dear, when we are talking about the derivative, so my dear, when we are talking about dx by d theta, obviously you can see that if you want to write the velocity of the follower, you will be writing the displacement ka derivative with respect to time. And guys, you can also write it as dx by d theta into d theta by dt. D theta by dt is nothing but omega dx by d theta. So my dear, the velocity is the first derivative, and this velocity is the first derivative. This velocity is the first derivative. So this first derivative is directly proportional to dx by d theta. So you can consider the first derivative to be dx by d theta because you know omega is a constant. Similar to that, second derivative is d square x by d theta square. My dear, dx by d theta is related to velocity that is given by physics, and this is the slope of x theta diagram. This is given by mathematics. So mathematics said this is the slope of x theta. Physics says this is the velocity. My dear, according to physics, velocity can be anything. Is it like that? No. My dear, according to mathematics, dx by d theta is slope, it can be anything. But when it comes to velocity, velocity of follower shall not be much. Dear Animesh, pressure angle will increases or decreases. That is not fixed whether going upward or downward. That will depend upon the cam profile. So I cannot guarantee you like that. But yes, it will be changing for sure. That depends on the cam profile, and that if it is increasing or decreasing will be mentioned to you. So don't worry about that. So guys, when we are talking about this thing, that is first derivative. Slope can be anything, but velocity shall have one limit. Because you know, follower once going up, it has to come back. Follower once going up, it has to come back. So if follower will be having high velocity, it is going to be very difficult for us to stop this follower. And my dear, without stopping, you cannot revert it back. So that's why velocity cannot be much more. Velocity is always lesser, always lesser, always lesser. So first derivative cannot be very, very high. We are coming on to the second derivative, my dear. It is related to, my dear, d square x by d theta square. You know, you have seen in the strength of material, in the mathematics, that there is an equation 1 by r can be written as d square x, d square y by dx square divided by 1 plus dy by dx to the power square to the power 3 by 2. And you know, r is related to d square y by dx square. So radius of curvature is definitely depending upon d square x by d theta square. Mathematics say it is related to radius of curvature. But physics says, my dear, this is going to be acceleration. So my dear, if d square y by dx square is going to be quite high, r is going to be nearly equals to 0. So my dear, as it will increase much, r will reduce to 0. According to mathematics, for a point, radius is 0. If you are taking a circle as a point, the radius is 0. Mathematics says yes, it is possible. But my dear, physics says acceleration is the parameter of motion. It is the motion parameter. And my dear, if it is motion parameter, it cannot be infinity. And my dear, by chance if acceleration is going to be infinity, it simply means that the contact between the road and the vehicle is not there, then only acceleration can be infinite, my dear, which is impossible. So my dear, definitely we cannot go for that. If you will be going for d square x by d theta square to be very, very high, acceleration will become infinite, and the contact between cam and follower, there are chances that it will be losing. But my dear, as you know, over the follower every time a spring is present. So as the spring is present over the follower, so when you are going to have the avoid or the chances that the contact between cam and follower is going to be lost, my dear, this spring will be applying the forces, and this is going to be a forceful contact. And when you will be trying for the forceful contact, my dear, follower will try to break the cam where the cam is having the 0 radius. So my dear, there will be a chances of undercutting of cam. So we never use very high value of this acceleration. If acceleration is going to be very, very high, my dear, follower will break the cam in between and it will become undercutting of cam. So my dear, very less number of peoples in faculties, they know that yes, undercutting occurs in cams also, not only in gears. So I don't say about the students. Okay. Yes, Animesh, that is fine. You are talking about the type of constrained motion. So dear, second derivative cannot be very, very high for a possible motion. Now we are coming to the third derivative. My dear, third derivative is d cube x by d theta cube. So my dear, physics says it is to be a jerk. And my dear, mathematics says that it is the rate of change of 1 by r, because you know d square x by d theta square is 1 by r. So my dear, according to mathematics, yes, the change of radii can be up to any level, but jerk shall not be very, very high. Because my dear, whenever the jerk is coming, let us say you are moving over a road and this road is not straight, this road is having this kind of speed breaker. So my dear, if road is having this kind of speed breaker, what you will do? This is my question to you. If the road will be having this kind of speed breaker, what you guys will do? I want to know. If the road will be having this kind of speed breaker, what you guys will do? I want to know that. If the road is having this kind of speed breaker, what you guys are going to do? I want to know that. Please tell me that. What you guys are going to do? I want to know that. What you guys will be doing? when you will be having this kind of speed breaker? You will be going to reduce the speed. Yes, my dear, I would like to say these presence of this type of speed breaker will result into vibrations or jerk, and to avoid these jerks in your motion, you will be reducing the speed. So my dear, once again, if third derivative is more, you have to reduce the first derivative. So my dear, if third derivative is more, you need to reduce the first derivative. But my dear, if second derivative is more, you cannot do anything. You have to do like this, that we are helpless. So my dear, the most dangerous derivative is the second derivative. It cannot be very high. Third derivative can be anything. If third derivative is more, we will reduce first derivative. Yes guys, wonderful, really wonderful. This is something related to the motions. Now my dear, I am coming on to the types of motion. The very first type of motion is uniform velocity motion. And my dear, when we are going for uniform velocity motion, then my dear, displacement curve is like this, because you can see velocity is constant. So my dear, this is rise, dwell and return. Rise, dwell and return. So my dear, for this kind of motion, I will be teaching you in a very less detail, because you need not to go into very much detail of that. In classes, I derived about everything. In classes, I derived about everything, because in class, I take camps and follow over for 7 to 8 hours. Here I am completing in 40 to 50 minutes. So difference you can know. So guys, if you are getting so much content in 40 to 50 minutes, you can understand what I will be teaching in 6 to 8 hours. Okay, but this batch is according to the qualification of GATE. Qualifier series is the name. So we cannot go into that much detail which I go for in the classes. Many students are there who have studied that in the classes. They are here for the revision purpose. They know up to how much extent we have done this. This is just a revision going on, guys. Okay. So when we are talking about uniform velocity motion, so my dear, it means velocity is uniform. So my dear, when we are saying velocity is uniform, the point is we are assuming that velocity to be uniform. But guys, our expectation is that velocity will be constant. This is our expectation, that velocity will be constant. But my dear, whenever you are saying velocity will be constant, velocity cannot be 5 meters per second at zero time. It will be taking some time. It will be taking some time to become 0 to 5. So my dear, when we are talking about velocity, okay, I am showing you the complete diagram here. When we are talking about displacement curve, it will be like this. This is rise, dwell and return. Rise, dwell and return. Now my dear, when we are going to make the velocity diagram, you must know one thing, that guys, velocity cannot become 5 meters per second at zero time. It will be taking some time. Like it will be going from 0 to 5 in some time, then will remain constant, then 5 to 0 in some time, then remain 0, then 0 to minus 5 in some time, then minus 5 for some time, then minus 5 to 0 for some time. Means for very less time in the initial, velocity is changing. For very less time in the end, velocity is changing. So my dear, for very less time, changes of velocities are there. So my dear, when we are going to see these changes, when velocity will be changing, obviously acceleration will be there. So we are assuming for this much instant, this is the acceleration. And for this much this is velocity reducing, so it will be retardation. Once again, velocity increasing in negative sense, retardation. It is again acceleration. Now you can see, guys, acceleration is increasing in zero time. So you know jerk is dA by dt. So if acceleration will be increasing in zero time, jerk will become infinite. So my dear, if you are going to make the jerk curve, here jerk will be infinite. Here jerk will be infinite. My dear, here the jerk will become minus infinite. Here again jerk will be minus infinite. Here it will be plus infinite. Because it is increasing in zero time, it is decreasing in zero time. Decreasing in zero time, increasing in zero time. So my dear, once again it will be minus infinity, plus infinity, then plus infinity, minus infinity. So 8 times jerk will become infinite. So my dear, 8 times jerk will become infinite. 8 times jerk will become infinite. 8 times jerk will become infinite. So when jerk will becoming infinite for 8 times, you need to reduce the speed for that. And my dear, when you will be reducing the speed, obviously this kind of motion, then obviously this kind of motion can be done, can be used only and only for low speed velocity. Okay, so that's the reason, my dear, uniform velocity motion is not used in too much of applications. Okay guys, hope you guys are getting it. So this is uniform velocity motion. So my dear, when we are talking about the next curve, that is basically uniform accelerated motion. So when we are talking about uniform accelerated motion, you must understand that, let us say these are the two extreme position, and you know in uniform accelerated motion how the motion is going on. This is the top and this is the bottommost position. Here the velocity will be 0, here also velocity will be 0. So my dear, if it is accelerated motion, there is only one way to go. First, velocity will be increasing to maximum velocity, then it will be going to reduce to 0 velocity. So here it is accelerated motion, here it is retarded motion. In the opposite sense, it will be increase in velocity in negative sense, so retarded. It is going to be accelerated motion. So here the velocity is going to be maximum in negative sense, means opposite direction. This is how, my dear, the things are going on. So my dear, when you are talking about this, for the first half of the rise, velocity increases, then second half velocity reduces, then velocity 0, then in the first half of return, velocity increase in opposite direction, then velocity reduce in opposite direction. So my dear, this is the velocity diagram. When you are talking about acceleration, this is accelerated motion, then this is retarded motion, then this is retarded motion, this is accelerated motion. Once again, acceleration is increasing in 0 time, so the jerk will be coming plus infinity, minus infinity, plus infinity, minus infinity, plus infinity, minus infinity. So my dear, this time 6 times jerk are becoming infinite. So my dear, here 6 times jerk becomes infinite. So once again I will be saying, my dear, as jerk is becoming infinite for the 6th time, it is used for slow to medium speed application. It is used for slow to medium speed applications. Now my dear, we are coming to simple harmonic motion. When we are coming to simple harmonic motion, my dear, this time when you will be solving it, you will be getting this type of curve. You can see this. When you will be having this type of motion, yes. So I am showing you for the simple harmonic motion, the velocity curves will be coming in this way. You can see this. And my dear, the acceleration curve will be coming like this. You can see this is dual, then this is like this. We can prove it, and in the classes we prove it, but here proofs are not required. So you can see here acceleration is increasing in 0 time, here it is increasing in 0 time, here it is decreasing in 0 time, here it is increasing in 0 time. So my dear, this time 4 times the jerk is becoming infinite. So my dear, 4 times jerk becomes infinite. This type of motion can be used for medium to high speed applications. And my dear, now I am coming to the last type of motion, and the last type of motion is cycloidal motion. And for this cycloidal motion, my dear, this type of velocity acceleration curve will be coming. This is velocity, this is acceleration, this is jerk. You can see this time, my dear, acceleration will not be increasing in 0 time. That's why, my dear, we will not be getting any infinite jerk. So as we are not having any infinite jerk, this type of motion is used for high to very high speed application. High to very high speed application. And my dear, here we have written the values of velocity, acceleration and jerk. So definitely till now, whatever the questions are coming, they are giving these values. They are giving velocity, they are asking for acceleration. You can differentiate it and find out this. Till date, this type of question have been asked more. But guys, in the classes, I used to derive all and everything. That's why I have shown you here. You can see the derivation if you want. But now the time is less. We cannot go for this derivation. Otherwise, CAM alone required 5 to 6 hours. It is a very big subject, theory of machines. So my dear, you can see the maximum value of acceleration, maximum velocity. You can remember that for your examination if you want. I will be sharing the PDF after the class. And guys, as I already said, we can go for derivation if you want, but time is not that much. It is simply differentiation 3 times, nothing more than that. Okay. So when we are going for jerk, there is no jerk becoming infinite. So it is used for high to very high speed. And that's why I said, my dear, when we are talking about this is used for IC engine valve mechanism. So for IC engine valve mechanisms, we are using this type of motion. So guys, as this series is for the revision purpose only, that's why I am not going much into the derivation part. Okay, like you can see, question from the gate, displacement is given to you and they have asked about the jerk. So you just need to differentiate it 2 times. When you will be differentiating, you will be getting velocity. Second differentiation will give you acceleration, 3 times. Third differentiation will be giving you jerk. So differentiating it 3 times, you can find out the answer what you want. Mohit, hello dear. So this is how you can go for. So guys, please tell me, do you want the derivations to be done or is it okay? Shall we move on to the gyroscope, the last topic? Because you know the derivations are quite lengthy, and if you're going for that, it will be taking long time, which is going to be wastage of time for you guys. Because you guys have seen the derivations in your classes. For revision purpose, we are looking here. So for that purpose, this series is awesome. For revision purpose, derivation part we can skip it here, otherwise it will be quite time taking. Yes guys, fine Adarsh, fine Ramesh Mohan. So guys, but I will be sharing you the PDF PPT. You can see the derivation there. Okay, in the classes I have done every derivation, because in class we have a very big time to solve them. We have basically a very long time, like 80 to 90 hours we have taken for theory of machines. Here we have covered in 10 hours. So this is a revision series. That purpose is to make you qualify in gate easily. Now we are going for the gyroscope, guys. So when we are talking about the gyroscope, first of all we shall see the angular velocity term. My dear, angular velocity term, it is a vector quantity. And my dear, to define a vector, we need magnitude, we need direction, we need sense of rotation. Okay, so we need magnitude, direction and sense of rotation. So my dear, when we need that 3 type of thing, so when we are talking about the angular velocity, you guys many times have said clockwise and anti-clockwise. But clockwise and anti-clockwise are not the direction, they are the sense of rotation. They are the sense of rotations. So my dear, they are the sense of rotations. So angular velocity is nothing but the sense of rotation. So my dear, when I am saying it is the sense of rotation, it is basically can be given the direction by the right hand thumb rule. Like let us say we are having a rotor. Let us say this is the rotor. This rotor is rotating clockwise as seen from this view. So if this is my view from this side, if I am seeing that this rotor and this rotor is rotating clockwise, I will be doing my fingers and thumb to be perpendicular to each other, rotating the fingers in the sense of rotation. Thumb will give you the direction. So my dear, the direction of omega will be this one. This is my dear the direction of omega. So this is the direction of omega. It is also known as my dear axis of spin. It is also known as axis of spin. So my dear, direction of omega is also known as the axis of spin. So my dear, if you are going to say this is said to be the axis of spin, and my dear, when you are talking about the gyroscope, gyroscope is nothing but an effect. So if you want to say what is this kind of effect, if you want to see that, we need to go for angular acceleration. So my dear, when we are saying angular acceleration, it is alpha vector. It is given as d omega vector by dt. You know omega itself is a vector quantity. To define a vector, we need to go for magnitude as well as direction. So my dear, if the magnitude is going to change, obviously I will say alpha will exist. If the direction is going to change, then also alpha will exist. So my dear, alpha will exist in both the cases. whether the magnitude changes or the direction changes. If both are changing, then also, my dear, if magnitude and direction both are changing, then also alpha will exist. So my dear, this alpha is responsible for two things: change of magnitude, change of direction. And my dear, when we are going to say, let us take a case where I am having this to be an axis, and my dear, the coordinate system we are using for gyroscope is x, y and z. If you want to learn that, my dear, this is like this. If this is x direction, this is z direction, y is towards me, y is inside. So my dear, this is the coordinate system used in gyroscope. So this is x, this is z, this is y. Y is positive inside. So my dear, I will say x is positive here, x is negative here. Z is positive here, z is negative there. And y is positive inside, y is negative outside. So my dear, these are the coordinate system we are using here. So in that case, if you are going to take the rotor, and I said this rotor is rotating with an angular velocity of omega, and my dear, let us say we are going to have a change of velocity as well as the direction. So after some time, I will say, if it is rotating clockwise as looking from this view, I will be saying that this is the omega vector, because it is clockwise as seen from this. So I will be making the direction of omega to be like this. And my dear, let us say this rotor is basically rotating like this, as I have seen, and by chance this axis of rotation is changing in xy plane. This axis of rotation is changing in xy plane. So when the axis of rotation is changing in xy plane, after some time you will be having this rotor to be along this axis. And I said the speed is also increased. So because the speed is increased, obviously the length of this vector, if previously omega, now this length will be increased to omega plus d omega. Yes, for sure. And my dear, at the same time it is rotated by an angle of d theta in the xy plane like this. So everything is going on in xy plane, but I will be showing it in xz plane, because in 2D I cannot show 3D. So my dear, this is omega at time t, and this is my dear omega plus d omega at time t plus dt. So it is rotated by an angle of d theta. So my dear, you can see initial and final vector are given. So this will be showing the change. If you see this change is having two components. This change is having two components. My dear, you can assume that this is first of all increased in magnitude like this, and then changes its direction like this. So this component is responsible for change of magnitude. It is said to be alpha x. And this component is responsible for change in direction. This is alpha y. So my dear, we can also assume it. Previously we were having this as omega, and finally we got this as omega plus d omega. So my dear, you can expect this is firstly increase in magnitude, then change in direction. Firstly increase in magnitude, then change in direction. So my dear, this change of magnitude is alpha x, change of direction is alpha y, and this is the resultant. So my dear, you can also write the alpha vector to be alpha x I cap plus alpha y j cap. So my dear, alpha axis responsible for change of magnitude, alpha y is responsible for change of direction. And my dear, when you will be calculating the value of alpha x, it will be coming out to be d omega by dt, and my dear, alpha y will be coming out to be omega d theta by dt. So if you see, omega is the angular speed, d theta by dt is the rate of change of theta, which is nothing but the motion, the rate of change of basically angular displacement, of the axis of spin. So my dear, if we are saying this is d theta, then if we are saying the motion of this angular velocity direction to be precision, then d theta by dt is the angular velocity of precision. So my dear, you can write it to be omega into omega p. And my dear, when you are talking about the gyroscopic couple, then gyroscopic couple is nothing but I alpha. And if we are assuming that alpha x to be 0, assuming omega to be constant in magnitude but changing in direction only, this is the fundamental assumption in gyroscope. You will be saying gyroscopic couple is going to be I omega omega p. So my dear, this is the magnitude of gyroscopic couple. Now we need to see the direction of gyroscopic couple. My dear, whether the case is of aircraft, whether the case is of, you can say, yes, ship, whether the case is of automobile, the way to check the direction of gyroscopic couple remains the same. So I am showing it once only, and with that we will be closing this session. We have seen that the direction of omega is like this. This was omega initial. And my dear, you know that this was omega initial, this was omega final. So you can say this is omega initial, this was omega final. If the magnitude is constant, only direction will be changing like this. So my dear, this is omega initial, this is omega final. And this is obviously the initial omega, this is final omega. So you can say that my dear, initial omega, final omega. So if you say with the right hand, this is the active couple, this is the reactive couple. This is active couple, this is reactive couple. So active couple is shown upward and reactive couple will be shown downward. But this is not upward, downward. Active couple is in this way, reactive couple is this way. This is active couple, this is reactive couple. Active couple, reactive couple. Active couple, reactive couple. And my dear, this is the reactive couple. And if this is the reactive couple, this is the direction of couple. If you want to see the sense of rotation, this will be given by the finger. So for the reactive couple, this will be the sense of rotation. So the device will be having a tendency to rotate like this. If let us say some fan is rotating like this. So this was the omega initial. This fan is rotating in this way. So my dear, you will be having a gyroscopic couple with this direction and this sense of rotation. So my dear, this will be having a tendency to go like this. Let us say some aircraft is going like this, and aircraft is going to turn in this way. So my dear, when aircraft is going to turn in this way, obviously omega initial is this, omega final is this. So active couple is this, reactive couple is this. So reactive couple will be having a sense of rotation of this, means aircraft will be having a tendency to move like this, to move like this. To move like this means the front end will have a tendency to lift up and rear end will be having a tendency to go down. This is how, my dear, gyroscopic couple will be acting. And my dear, every case we are finding out the direction like this only. But as I said, my dear, today we have covered the 3 topics which I take in classes for 20 hours. We have completed them in 2 hours. So by looking at the content of 2 hours, you can have an idea that what we would be discussing in the classes. So 20 hours, 2 hours, a very big gap. So goodbye guys for this session. Thanks for joining. Please like, share this session to everybody, to your friends. And goodbye guys, as the electricity has also gone. So I need to close here, and we have completed all the 3 topics. Goodbye guys for this session. Thanks for joining once again. We will be meeting in other series which are going to be there in the February month. Once again, goodbye guys.